Hello wonderful person, this is Anton, and in this video we're going to be discussing this ridiculously massive structure visible from outer space that has recently once again reappeared in the Atlantic Ocean. And this one is so large that it's technically stretching over 5,000 miles or nearly 9,000 kilometers across, making this one of the largest biological structures on the planet. And based on recent calculations and recent observations, it looks like it's only getting larger and larger every single year. And so in this video, let's actually discuss this somewhat less known phenomenon referred to as GASP or Great Atlantic Sargassum Belt, talk about exactly what this is and how it's formed, and what this tells us about our planet. And in this case, this is actually a really intriguing phenomenon because for centuries, we believed that we understood the distribution of life in the Atlantic pretty well. But since 2011, or approximately 15 years ago from when I'm making this video, a completely new phenomenon started to emerge that's now challenging our understanding of both ocean chemistry and global nutrient cycles. With this structure essentially representing something we never expected and never predicted to exist, especially because it seems to have developed extremely quickly. And though this basically might sound like some kind of a patch of seaweed, in this case its rapid expansion and its rapid development tells us a pretty complex story that we need to understand a little bit better before we can start making any conclusions. But first, I guess the obvious question: so what is sargassum and how exactly does this form? Well, technically it's just this. It's a genus of brown macroalgae, or brown seaweed, that's quite unique because it doesn't grow attached to the seafloor and instead spends its entire life floating on the surface. And it manages to do this because of these very unusual small gas-filled bladders referred to as pneumatocysts. They essentially kind of resemble these really tiny grapes, with these bladders providing buoyancy, allowing this algae to float on the surface where it can basically access maximum sunlight for photosynthesis. So it's actually a very clever survival strategy. But there might be a chance you've never seen this anywhere, because historically it was actually only known to exist in what's known as Sargasso Sea, which is actually named after this particular seaweed. And this sea is also intriguing because it's the only sea in the world that does not connect to any land. It's actually bounded by a bunch of major currents. And so hundreds of years ago, the Portuguese explorers that were exploring the Atlantic observed extremely large masses of this floating seaweed all over the water, and they decided to name this particular area after the Portuguese word for plant, sargasso, even though technically it's not a plant because it's a seaweed. And ever since then, for centuries, this area was shrouded in a lot of mystery, mostly because of these early explorers, including Christopher Columbus, who were actually pretty scared of this area because the abundance of the seaweed made them believe that their ships are going to be trapped in it and might never be able to return back home. And so it both confused and terrified sailors for a very long time. But in reality, one of the main reasons why there is so much sargassum in this region is because of a kind of a trapping effect produced by the oceanic current that creates a circular current. This is essentially what you're looking at right here. And so because this particular seaweed always floats on the surface, it generally gets stuck in this region and tends to grow pretty well in these somewhat calm, somewhat warm waters. As a matter of fact, for the marine life, these unusual forests are extremely important because they tend to develop their own massive ecosystems. And that's because a lot of different types of life, such as this sargassum fish, have now evolved to survive specifically inside these forests by essentially evolving a lot of types of camouflage that makes them resemble the seaweed. And so over 100 species of fish and 145 species of invertebrates seem to survive uniquely inside these floating mats and cannot survive anywhere else. So it's basically become a kind of a nursery for many different species. And it's been doing so for millions and millions of years. Some of the earlier fossils seem to be at least 30 million years old and come from a very similar location. But if this existed for so long and seems to be so important, what is this new structure we're discussing today? Well, up until 2011, most of it basically stayed in the Sargassum Sea. But in the spring of 2011, thousands of tons of this began washing up on the Caribbean beaches. And well, generally it resembled something like this. As a matter of fact, there was so much of it everywhere that in some cases it also started affecting the local ecosystem. Now, small amounts of sargassum appeared here and there, but never in these amounts, and never to such an extreme extent. And well, the thing is, ever since then, for the past 15 years, there's been this massive shift that's now been increasing the amount of sargassum appearing every single year. And all this potentially started sometimes in 2009, 2010. This was actually during the extreme negative phase of the North Atlantic Oscillation that created these very unusual wind patterns that pushed a lot of sargassum from its traditional area toward Gibraltar and Africa, thousands of miles to the east. And here, once it reached these warm waters, it actually found a perfect environment to explode in growth. And that's essentially what you're seeing here. These were space images taken by NASA between 2011 and 2025. And every single year, there is more and more of it appearing coming from Africa. And well, since then, in these last 15 years, it essentially formed this extremely massive, very long belt, over 5,000 miles, nearly 9,000 kilometers in length, that forms every single year and is actually getting larger and larger, with the measurements in May of 2025 establishing this at approximately 38 million tons. In other words, the sargassum mats that existed in the Atlantic for centuries have now started to appear in excessive numbers and actually started to cause significant environmental issues in a lot of different regions. Mostly because, as they wash ashore, they generally rot, producing a lot of somewhat toxic elements. They also dramatically reduce water quality, they block sunlight for a lot of other species, and tend to negatively impact a lot of life in the area. As a matter of fact, the release of hydrogen sulfide gas alone has already caused problems for a lot of different locations in the last decade. And well, the question is, why? So what exactly happened and what is happening? And is this actually going to get worse? And should we maybe start worrying about this as well? Which is essentially what a lot of these recent studies that you can find in the description try to tackle. Here the focus is on examining this recent sargassum bloom by essentially trying to figure out what's causing all of this and why this sudden change occurred. And so what's causing the tsunami of seaweed coming from Africa? And based on these recent studies and a major review of 40 years of data, not surprisingly, there seems to be a lot of effect from human activity. And that's because generally these types of seaweeds only need two main nutrients to grow and to proliferate. They need nitrogen and phosphorus. And historically, sargassum was always limited by how few of these nutrients were in the open ocean and were basically in a kind of a oligotrophic state. These nutrients would appear seasonally and would mostly concentrate in specific areas. But since 1980s, researchers discovered that the nitrogen content in the sargassum tissue seems to have increased by at least 35%, whereas the ratio of nitrogen to phosphorus doubled, with this nitrogen enrichment pointing at something that seems to be happening on land. And all of this seems to be the result of wastewater, deforestation, and synthetic fertilizers. Okay, so let's briefly break this down. When it comes to fertilizers, in the last few decades, the production has increased by nearly 10 times. And most of this actually ends up washing into rivers like the Amazon, which then release all of this in the Atlantic Ocean, enriching nitrogen in the locations where you basically see all of this sargassum. And a lot of this water also contains wastewater from untreated sewage, as well as additional industrial outputs, all of which basically end up in the ocean, with deforestation of the Amazon basin increasing the nutrient runoff as well, and basically creating a perfect mixture for all of this sargassum to grow. And so here the chemical analysis confirmed that both the Amazon River and the Mississippi River seem to act as these giant funnels, dumping all of these nutrients into the Atlantic, which the seaweed then uses to create these massive mats. And so by having so many nutrients all at once, sargassum essentially goes into overdrive and manages to double its mass in just 11 days. Which also brings us to this somewhat paradoxical phenomenon referred to as the paradox of enrichment. So usually, more nutrients mean more life, which we might think is good. But too much of a good thing can generally destabilize the entire ecosystem, which is exactly what's happening here. And so while sargassum is definitely a vital habitat for a lot of different life, at least in the open ocean, once it reaches the shore, everything changes. In these massive amounts, it actually becomes harmful to a lot of life near the shores and can actually result in a major collapse of the ecosystem. And here, it does not just affect the tourism, it affects pretty much everything living in these waters. For example, by producing hydrogen sulfide, in 2018, over 11,000 people in the Caribbean were actually diagnosed with acute poisoning from this gas. And naturally, this also affected a lot of other life, including these fish. It also, as you can see in this video, blocks sunlight, which then ends up smothering a lot of corals living underneath and killing any other seaweed living on the seafloor. And when the seaweed dies, it also consumes all of the oxygen in the water, which tends to create dead zones where fish cannot survive and end up suffocating. And so basically this is now a pretty big problem in a lot of locations in the Atlantic, with some of the most recent studies discovering that there are so many nutrients in the water now that the vertical mixing basically creates a perfect environment for all of this sargassum to thrive for many years. At least in the tropical Atlantic, where winds usually cause nutrient-rich water to rise to the surface. So this is not going to be disappearing anytime soon. But the study also confirmed that if it wasn't for that unusual anomaly in 2010, the anomaly that moved all of the sargassum to Africa, the structure likely would not exist today and would still only be in the Sargasso Sea. And so it took less than a decade for the structure to become enormous and to essentially spread across this whole region. As a matter of fact, sometimes the chunks of this are so large that they're visible from space. This one here is approximately 1 kilometer across. And so by itself, this is not just some kind of a giant seaweed patch, it is a direct indication that we're also changing the chemistry of the oceans, which then changes what happens on the surface and what sort of life seems to thrive in them. Or basically it shows us that what we do on land and how we farm or how we manage waste and how we treat our forests has a direct massive consequence thousands of kilometers away in the deep ocean. But as Winston Churchill once said, never let a good crisis go to waste. And that's exactly what's been happening in the last few years, as some teams now start looking into ways to turn this problem into some kind of a resource. For example, using the seaweed for biofuels, compost, or even some kind of a algal mining principle in order to recover certain rare earth elements. Now, nothing concrete has been made just yet, but considering the enormous size of the structure and how it seems to spread across the ocean very quickly, I would not be surprised that in the next few years, someone will actually come up with some kind of a functional way of mining this and recovering something really important as a resource. But on that note, because we don't really know much else, I'm just going to end this here. This is a brand new phenomenon that's only been around for less than 15 years, and that means that we're still going to be learning about this for years to come. I'll come back and talk more about this in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.